Next step that I want to look at is a graph of a function. You pick any problem in which we are given a lot of conditions. We will always have these kind of problems throughout each chapter and many sections in each chapter. We're given information about a function. We are asked to find or come up with a graph, and there's more than one correct answer. So please choose any problem you'd like to work on. We want to work on 17, so let's copy 17. And this is on page 97, and we have limit. I'm copying right now. I'm not organizing anything. I'm just copying. X approaches 3 from the right. Limit of f of x as x approaches 3 from the left. Limit of f of x as x approaches -2 from either side. F of 3 is 3, and f of -2 is 1. I didn't do anything. I didn't think of any step just yet. I only copied the information given in the problem. Okay. Now I will organize the information. Again, organize the information in some way. You choose, but you have to show your work. I recommend what I'm doing because you're going to see these tables throughout the entire course. You're not going to see it in chapter 5, but you're going to see this table all the time before that. Okay, so this is x, and this is f of x. And I will start with f of 3 is 3. Don't cross it out like that. I'm just making a point. And then f of -2 is 1. Done. Now carefully, let's read the rest. The limit from f of x as x approaches 3 from the right is 4. The limit of f of x as x approaches 3 from the left is 2. Finally, the limit of f of x as x approaches -2 from either side is 2. Okay, here's my example of a graph. You can create your own if you don't like mine, or even if you like mine, you still can create your own. -2, 1, 3, 3. So -2, 1, and 3, 3. And now, on the left-hand side and right-hand side is 2. Left and right is 2 and 4. There are infinitely many correct answers. This is my example. I was given 2 ordered pairs, -2, 1, and 3, 3. I was told the limit from either side of -2 is 2. And I was told that the limit from the left of 3 is 2, and the limit from the right is 4. Any questions on this? Any questions on this?
What was the question? Was it just graph?
Yes, we were asked, we were given information about the graph, and we were asked, very good question. I thought I said that, but it was not enough. Sorry about that. So, sketch the graph of an example of a function f that satisfies all the given conditions. Better? Sorry about that.
No.
Yeah, but it's I didn't read it with you, so it wasn't clear. Sorry. Any questions on this problem? Yes, please. Sorry.
How do you know what the shape of the graph looks like, or you just guess?
You do whatever you want. If you don't like this, just do this. You can do whatever you want. As long as the given conditions are fulfilled, are presented, the rest is up to you. You can put a vertical asymptote here and do this. You can do whatever you want.
But those two dots are equally a part of the function.
Everything is part of the function. These are part of the function. These are everything you see here that is graphed other than 0 and x and y, they're all part of the function. This is my function that fulfills the given conditions. Any questions? Very good questions. Thank you. Okay, I would like now to look at what's called infinite limits. I don't like to put the title in, but I will because I want you to know what they mean, what I'm talking about. But I really wanted to put the title later. Infinite limits. Okay. Let's go back for a second. I just want to clarify one thing here. I know it's clear, but I will say it several times. But when we determine the limit as x, let's say, approaches 5 or xx approaches 3, doesn't matter. The word approaches is a key word here. Because we really mean at all times that x does not equal 3. In this case, that x does not equal 5 in the previous case, etc., etc., etc. So we really mean x does not equal 3, x does not equal 2, x does not equal 5. Okay. So every time we calculate the limit, I'm going to say something that contradicts what I just said a second ago. We will plug it in. And you should say, well, wait a minute. You just told us that x does not equal 5. Why would you plug it in? You just told us that x does not equal 3. Why would you plug it in? Because there are many, many different types of limits that we are going to look at. Does anyone have that handout? Sean, do you have the handout with the limits here by any chance? Can I just borrow it for a minute? Perfect. Okay. So we're going to go through all these limits. So this is the handout. It's also posted. If you don't have your copy, I may be able to find another. So all these types of limits. And what will I do? Will I always plug it in? Yes. I will not tell anyone. Of course we will, but it's nothing illegal. We have to do that because we don't know what type of limit we're facing. So again, we're going to work on each and every one of those. Not this moment. So when we plug it in, we will encounter the following two possibilities. This is not 0. So when we plug it in and determine what type of limit we are looking at, we will encounter in general these two options, either 0 or 0, or infinite, or a number of a 0. I want to caution you that there are 7 indeterminate, not undefined, but indeterminate cases. What is an undefined situation? This is an undefined situation. This is an undefined situation. This is an indeterminate case, and this is our first that we are looking at. We're going to look, we're going to encounter all 7, but for now, this is our first. What does the indeterminate case mean? Anything. This answer of this limit may end up being 15. It may end up being undefined. It may end up being infinity. It may end up being anything. So that's why it's an indeterminate case. The undefined case is dead. There's no hope that the limit exists here, ever. But this one has hope. So the indeterminate case, because we have no idea what to expect, it has hope. So there is hope. that the limit exists. This one never, no hope. The limit will never exist in this situation. This one has 3 possibilities as answers. This one, I have not even a clue what we can come up with. Anything. 1, e squared, anything is possible. So I can't give you options. But for this one, there are only 3 possibilities. Negative infinity, infinity, or d and e. So in all situations in which we have a number, not 0, in the numerator, and 0 in the denominator, there is absolutely no hope. Don't even try. This is one of the answers. D and e, infinity, negative infinity. And 0 was 0, and the other 6 cases that I'm not going to mention right now, there is hope. Okay. So in view of this, let's finish this section, which is 2.2, with any example you'd like, but allow me to choose the first example from these. Allow me to choose the first one, and then you'll choose the next. Anything you want. So I'm going to start with 30. X plus 2 over x plus 3. So this is 30 on page 98. And we have limit as x approaches negative 3 from the left of x plus 2 over x plus 3. So we're asked to calculate this limit. What is the first thing we need to do? What do you think? When we calculate the limit, the first thing we have to do is plug it in. Although you can say, didn't you just say that x does not equal negative 3? Yes, I did. X does not equal 3. This arrow means x gets closer to negative 3 from the left, but it does not equal. And then who allows me to plug it in? If I don't plug it in, I don't know which case is it. So I have to plug it in. So when I plug in negative 3 at the top, what do I get? Excellent. When I plug in negative 3 in the denominator, I get? Good. So I know for sure that there is no hope. And I know that I can only come up with positive infinity, negative infinity, or d and e. Now, in the next step, we are going to plug in a number very close to negative 3 from the left-hand side of negative 3. Please don't say negative 4 because it's way too far. So give me a number to the left-hand side of negative 3 that is very close to negative 3 from the left.
Negative 3.2.
Negative 3.2, excellent. Good. What is the numerator again? I just need the sign. Negative. What is the denominator with negative 3.2 in it? The sign. What is negative over negative? What does that mean? What does x equals negative 3 represent then for this function? Thank you. So x equals negative 3 is a vertical asymptote. Excellent. Now please choose anything else you want. Which one?
35.
35. This one. Very good. So in 35 on page 98, 35, we have limit x cosecant x when x approaches, I think it's 2 pi from the left. Yes, it is. Ready? Okay. So we're asked to find a limit. What is the first thing I need to do? Yes, I have no choice. So this is just 2 pi. There's nothing I can do to 2 pi. But now, this is cosecant 2 pi, because we want to go to simple trig functions. What does cosecant equal to? Very good. Excellent. So can anyone give us sine of 2 pi? Yes. So this will be 1 over 0. 1 over 0 times 2 pi is still 2 pi over 0. So I know that this situation is either negative infinity or DNE. Very good. So we have 2 pi basically over 0. Who cares? It doesn't matter. The number at the top doesn't count. Okay. So now you can rewrite, if you'd like to see it, maybe this is better if we do this. It's x divided by sine x. The numerator goes to 2 pi and the denominator goes to 0. So I don't want you to get confused. So this is our discussion. Okay, so good. Now 2 pi from the left. This is 2 pi. We start here. 2 pi from the left stops shy of 2 pi, which is which quadrant? Very good. The numerator is 2 pi, so this is a positive number no matter what. But I'm trying to establish the sign of sine in the fourth quadrant. Negative. So positive over negative. We knew that we had to have one of these. There was no choice, no other choice. That's it. All I had to establish was the sign. So the top is always positive with 2 pi. It's a positive angle. The denominator is 0, but I really need the sign since we are coming from below 2 pi with angles smaller than, but we are close. We have to be close in the fourth quadrant, where we know that sine is negative because sine is measured on the y-axis. So it's positive above the x-axis and it's negative below the x-axis. Therefore, we get x equals, the limit is negative infinity, which means that x equals 2 pi represents what for this function? Which function? X cosecant x. What does it represent? A vertical asymptote, of course. Any questions? Any questions?
Now, is it always the case in the where it's with the problems that we just did, the approaching either like -3 or 2 pi, the answer will always be a vertical asymptote?
If the answer is infinity. If the limit is infinity, otherwise no. So if this answer is, for example, 4, x equals 2 pi is not a vertical asymptote. The vertical asymptotes require at least one side to go to infinity or negative infinity. So for example, at 0, at least one side goes to infinity, where x equals 0 is a vertical asymptote. At 6, at least one side goes to either positive or negative infinity, x equals 6 is a vertical asymptote. If the limit left and right is 4, that's not a vertical asymptote. Better?
Yes.
Perfect. Good. So any questions?
The part where you're saying it's negative infinity, infinity, or gaining, is the example there in the case, like I think earlier on you had, essentially if it's negative infinity from both sides, it's going towards that.
Correct. But look here, it's 2 pi from the left. I'm not even analyzing the limit from the right. So if I don't have this, then I have this situation of a number over 0, I have to determine both limits, left and right, because I cannot make a conclusion. So it's either DNE or infinity or negative infinity. So I have to determine both sides. But since this is specifically from the left, and this was also specifically from the left, there is no need to determine the limit from the right. It's a very good question. But if I have, it's a very good question. So if I have this situation, thank you for asking that. If I have limit as x approaches 1 from either side from 1 over x minus 1 squared, I know it's 1 over 0, but there is nothing I can do about it before I find the limit as x approaches 1 from the left and limit as x approaches 1 from the right. If this is infinity and this is negative infinity, then this is DNE. If this is infinity and this is infinity, then this is infinity. If this is negative infinity, then is negative infinity. Well, obviously this is a positive function. It could never be negative infinity. This is always positive no matter what. So it is 1 over 0, but this is always positive. No matter what you plug in here, left, right, doesn't matter. This is always a positive number. So this will be infinity, this will be infinity. Therefore, from here, we get that from either side is infinity. Any questions? Is this okay?
Is there going to be a scenario where that DNE is like a deleted neighborhood or something that we have to deal with?
You mean when you get something like this?
Yeah.
This is DNE. If this is positive and this is negative infinity, that's DNE. Or vice versa. That's DNE. But then this is a positive function, I will never get a negative infinity out of it. It's not possible. No matter what I plug in, I have to square it. So this is always a positive number. But I get 1 over 0, so it has to be infinity. Is this okay? Everyone? Yes? Okay. Moving on. Okay. Finally, we get to some limit laws. 2.3. Limit laws. Your book presents like 11 different limit laws. I truly believe that many of them should not even be considered limit laws, but that's okay. I'm gonna say it's fine. So this is these are the preliminaries. First of all, the assumptions. Without these assumptions, we cannot apply the limit laws. Since we're going to be looking at two different functions, I'm going to say that limit of f of x as x approaches a from either side exists. Let's say it's a number L. And another function, limit of g of x as x approaches a from either side exists as well. And I'm going to say in general it's just a number m. Can we put a number in those? Yeah, they can even be equal. It doesn't matter. So here is our first limit law. The limit of f of x plus g of x as x approaches a from either side. A wild guess. What do you think this will equal to?
The limit of x approaches a plus the limit of g of x.
Common sense. Thank you. The limit of a sum is the sum of course. With only one condition. As long as these limits exist. Otherwise, you cannot break it up. So then, if that's the case, this is the final answer is L plus M. In the same limit, in the same law, I would like to do this. Not because I'm lazy, but they really belong together. So if I have a difference, then is the difference of limits. If I have a sum, then is the sum of limits. So they do belong together. So we should not have them separated. Every now and then I'm going to go back to a function just to refresh your memory on the graph because we're going to see it throughout. So here's one function that I would like to, I didn't finish. I have another 9 to go through. But I'd like us to refresh our memory on this function. Anyone remembers what this function is, first of all? Rational. Anyone remembers the graph of the rational function? Where will this function be undefined, by the way? At? Of course. So that's why it has a vertical asymptote at 0. And it's positive on this side, and is negative on the other. And this is the graph of 1 over x. Can anyone give us the limit from the left of 0? Negative infinity. Can anyone give us the limit from the right of 0? And the limit from either side? Excellent. And now I want to give you an example of this. Allow me. So I want us to use this limit law on 1 over x minus 2x as x approaches 0, let's say from the left. And I want to write that limit of 1 over x as x approaches 0 from the left minus limit of 2x as x approaches 0 from the left. I'm using the limit law. Agreed or not?
Agreed.
Say it again.
Agreed.
Sean agrees. Anyone else?
Oh, no, because 1 does not exist.
Of course. That's what the assumption was. If this is not a number, or this is not a number, one or the other, or both, I can't split the limit. It's not allowed. I can't do it. Because the limit of 1 over x as x approaches 0 from the left is negative infinity. It's not a number. Questions? Is this okay? So please make sure that the assumptions are fulfilled when you use any of the limit laws. Next one? Yes? So this should be number 3, but I'm going to make it into number 2. The limit as x approaches a from f of x times g of x. Assuming the assumptions are fulfilled, what do you think this will equal to? My markers are drying out. Limit of f of x as x approaches a multiplied by limit of g of x as x approaches a. Of course, this will equal L times m in our example with L and m. Very good. Common sense so far, correct? Yes? Okay, number 3, the limit. What do you think I'm going to write now? Again, it's common sense. What is it? Yes, of course. Is limit of f of x over limit of g of x, of course, as x approaches a. But this time I have to write a big if. What is this big if all about? Limit of g of x as x approaches a does not equal 0. In that case, so assuming it will be L divided by m. So m cannot be 0. Any questions so far? Any questions? So the limit of a ratio is the ratio of the limits. Okay, so next one. Limit of a constant as x approaches a from either side. What do you think this will equal to? Yeah. Yes, of course. Who cares where x is going? Poor constant stays the same at all times. Perfect. Next. Number 5. Limit as x approaches a from either side of x. Of course, you'll plug it in. And what will you say? What is the answer? A. Indeed. And you can say, well, wait a minute, you just told us not to plug it in because x approaches a. True, but this is a polynomial, and limits of polynomial functions will always give us the same answer if we plug it in. Why not, then? Okay, 6. The limit of a function raised to the nth power as x approaches a. And n is a positive integer. Because if it's a negative, it's 1 over, and it's a different story. Okay. Before we write this answer, I would like us to discuss a theorem, but I'm not going to go into details because we're going to use it later. But in this particular situation, we're going to write limit of f of x as x approaches a. And this is allowed only under certain conditions, which is what we're going to talk about in this chapter. So this is under conditions of continuity. No details right now, but if the function is not continuous, the whole thing collapses. Okay, so I cannot do this. This is called, the way I like to call this theorem is swapping of, what do you think? What are these? What is this? What we operators. I swapped the operators. I put the limit operator inside, close to the limit, to the function, and I took the power operator outside. And the answer, of course, is L to the n, because the inside is L, and then the power is n. 7. And you'll tell me how to write this one. And which operators we swap this time. Of course, n has to be a positive integer. Not 0, not 1. 2 and above. So what will you write? The nth root of the limit of f of x as x approaches a. Under the same conditions of continuity, I was allowed to swap the operators, and the answer will be the nth root of L. Any questions? Okay, finally, these are, again, should be together. The limit of x to the n as x approaches a, and the limit of the nth root of x when x approaches a. These are special cases of the previous ones. Really, they should not be separate, but it is what it is. So what will you give me as the answer of the first one? Good. Okay, enough of this. I would like us to, we already know this, we don't have to make a big case out of it, but let's read it together. Direct substitution property. If f is a polynomial or rational function and a is in the domain of f, then just plug it in. We've done that several times today. The limit of x is a. The limit of x to the nth is a to the nth. The limit of, okay? So that is allowed because it gives us the same answer. Okay, I would like us to go through several problems, and you choose. We are asked to evaluate limits. There are many, many different limits, and we're going to start now working on this handout. It will take us a while. It's not gonna. We're gonna be not gonna be able to finish up all the handout in one session because we're not done with all the material yet. So, please choose from here. Which one?
17.
17. Okay, let's start with 17. So I know I have about 20 minutes left, so we're gonna just practice limits right now. Everything is on page 107. And we started with 17. So this is limit as h approaches 0 from -5 plus h everything squared minus 25 everything divided by h. Okay? We're given a limit. We're asked to find it. What is my first step? No matter what. Yes, I have to plug it in. So please tell me what you get at the top in the numerator when you plug it in. 0. And when you plug it in the denominator, what do you get? Oh, that's nice. Why? Because there is hope. It could exist. Not necessarily, but it could exist. If I have 5 over 0, I know that's no hope. Good. Okay, so then we have limit as h approaches 0. What do we do to the numerator? We have several ways. We can factor it or simply square and subtract 25. Which method? Fine. So if you square binomial, please make my day and say how many terms we get, please. 3 terms. Very good. So please give me 3 terms. Very good. Minus 10h plus h squared minus 25. By the way, let's take a look at it and see, what is this? The difference quotient, of course. All terms without h have to go away from the top, and eventually h in the denominator will go away. Excellent. Thank you, Sean. Okay, so these two go away. The numerator has 2 terms, and they have a common factor, which is, please pull it out and tell me what you have in parentheses. So yes, you can do that. That's fine. Now I simplify. And now this becomes a polynomial. And we just read the theorem that says, when it comes to polynomials, plug it in. What is it? What do I get when I plug it in? -10. Great job. And that's the limit. By the way, since we already identified that this is the difference quotient, and we put a limit operator on the difference quotient, this is the difference quotient, and this is the limit of the difference quotient. What do you think this will represent? Remember what I said when we started today, when we talked about the difference quotient? I said this is almost, not exactly, almost the slope of the, or the instantaneous velocity, or the slope of the tangent line. What do you think now will happen when I put this operator in front of the difference quotient? It is. Without this, close. But with this is definitely the instantaneous velocity if the function is a distance, or slope of the tangent line, or, this is for later, the derivative function. All the same. Of course, these are at a particular value. This is the function itself. So maybe I should write that all these at a number, because the answer is a number, but this one is a function. We'll differentiate these definitions later. Good. Okay, let's choose another, or we can go through some of the handout. So it's up to you. You want the book or the handout? Okay, so let's start with, we cannot do all of them today. You'll see why. So let's start with the first one. And that is limit as x approaches 2 from x squared plus x minus 6 over x minus 2. We're asked to determine this limit. What is the first step? Mandatory step. Plug it in. Very good. So let's plug it in. What do we get at the top? Perfect. What do we get in the denominator? 0. So there is hope. Okay. Now, before we continue, we have to talk about something very important. If I have a polynomial, like for example this one at the top, and I plug in 0, what do I get? Good. This means that x minus 0 is not a factor. Of course, x, I don't need to put minus 0, is not a factor of p of x. Now I want to plug in negative 3. What do I get? 9 minus 3, 6. Minus 6 is, what does that mean? That x, careful, x plus 3 is a factor of p of x. What if I plug in 2? You already told me I get 0. What does this mean? X minus 2 is a factor of p of x. So bottom line, why am I discussing this? This is called the remainder theorem and the factor theorem. So these two together, remainder and factor theorem. Theorems. Why am I talking about this? Because I want you to know and remember that when you plug in 2 in a polynomial, the culprit is x minus 2 because you get 0. When you plug in 2 in the denominator, you still get 0. That is the culprit. So if I make an x minus 2 disappear from the top with an x minus 2 disappear from the bottom, I'm in business. I know that that is the problem. The x minus 2 approaches 0. I know that x minus 2 is the problem. If I remove it from the top and if I remove it from the denominator, I get a limit, hopefully, because I can still have a 0 left in the denominator. So I don't know, and not in this case. So then I know that this is limit of x plus 3 and x minus 2 over x minus 2. I knew that that factor had to be there because when I plugged in 2, I got 0. So it has to have a factor of x minus 2. I got rid of the problem, and now the limit is, indeed, Because as we know, the limit of a polynomial, we just plug it in to get the limit. Any questions? But please remember this. This is the theory behind why I'm looking for getting rid of x minus 2. That's what I'm looking to get rid of x minus 2. Because I plugged in 2 in a polynomial and I got 0. Therefore, x minus 2 is the problem. If I plug in negative 3 and I get 0, then the problem is x plus 3. Okay, so let's take a look at the next one. The next one is a more complicated situation. I do have time. I have 12 minutes left. So we can look at this. Or we can continue with something else and come back to that later. This is a very important type of problem. It has absolute value in it. So we want to continue with this. I know you're tired. I know it's a lot. 2 hours, it's a lot. So if you think that we should have a 3-minute break in the middle, we can. It's up to you. You decide. I don't want to lose your attention, so I'll do anything. You can come up with some jokes. Okay. What is this? And the answer is, I have no clue. I really have no idea what this will come out to be, but I have to take it piece by piece and simplify the function first. So we will start with the absolute value of x, because that's the problem here. Why? Because the absolute value of x has 2 options. Nothing else has 2 options. 1x, they don't have 2 options. This is the problem. It has 2 options by the formal definition of the absolute value. So let's talk about the absolute value. It's a piecewise defined function. It's not friendly. It has 2 different pieces. So can anyone give us any of the 2 pieces? So it's x if x is greater than or equal to 0. And the other option for x, that's it. Whatever it's here, it's not here, it must be here, and vice versa. Okay, perfect. Okay, now, I'm not interested in the absolute value of x. I'm interested in 1 over the absolute value of x with 1 minus x in front. So 1 over x minus 1 over the absolute value of x, because this piece has 2 options. The entire function now has 2 options. So what is the first option? This does not have 2 options. I have to copy it. The minus does not have 2 options. The top has 1 option, but the absolute value could be x. Now I can no longer use the equal symbol because this was not in the denominator, but this one is. So I can write only this. Is everyone okay with that? Yes? No? So this was not in the denominator, but this is in the denominator, so I can no longer put the equal symbol. I cannot have 0 in the denominator. Is that okay? Can anyone dictate the second option? 1 over x and minus and 1. But what is the other option right here in the denominator? Indeed, for x less than 0. We're not far from simplifying this function fully. Okay, what is the first branch, please, for x greater than 0? You have an apple and you give it to me. Good. But now careful. Minus minus changes into a plus. So you have an apple and I give you an apple. This function is completely simplified. It has 2 branches. Right of 0 is 0. Left of 0 is 2 over x. Only now I go back to see what I'm asked to find. So I'm asked to find the limit of this function as x approaches 0 from the left. But now I know exactly which branch, not the whole thing. Which one is 0 from the left? 2 over x. So then I have limit as x approaches 0 from the left of 2 over x. This is one of the reasons why I refreshed your memory on, was it that far back? On 1 over x. 1 over x or 2 over x doesn't mean any different. It's not a big difference. So then what is the limit of 2 over x as x approaches 0 from the left? Because it's 2 over 0. I know it does not exist. But I cannot write d and e unless that's the answer. So then I have, which means x equals 0 is what for this whole function? So we have options now. We can look at another, of course, many of these problems from the handout come from your book. So this is the problem that we just went through. So we can choose another absolute value, or we can choose something else, or we can continue with other problems from the handout. There are many, many, many different types. Say it again.
Number 3 on the handout.
Number 3 from the handout. Let's take a look. Sean, I'm sorry. I have it, but I don't want to waste your time and make you wait, so that's why. Number 3. Very good. Limit as x approaches 2 from the left, x squared minus 2x over x squared minus 4x plus 4. Very good. We're asked to determine a limit. What do we do? Good. Top. Excellent. Denominator. Good. We know that there is hope. There is no guarantee. I'm only saying there is hope. We'll see. So there is no guarantee, but there is hope. That is something. And I know what the culprit is. What do I need to get rid of immediately? What do I need to get rid of immediately? Let's go back. I know it's a lot of information in such a short time. So let's go back. We have two polynomials, one at the top and one at the bottom. We plugged in 2 in both of them, and we got 0 over 0. I know for sure that the top has a factor of, and I know for sure that the bottom has a factor of. Good. So coming back now, what do I have to get rid of immediately? Right. I have to have an x minus 2 and an x minus 2, and we'll figure out the rest in a minute. But once I plugged in 2 and I got 0, both top and bottom have to have a factor of x minus 2. Maybe something else. I don't care, but I know that at least one x minus 2 will come out from the top and one from the denominator. Agreed? Okay then. So now let's figure out how we factor the top, what is in front. Good, that's done. Let's look at the denominator. Good, excellent. So 1 from here with 1 from here. So now I'm looking at the limit of x over x minus 2 when x approaches 2 from the left. I plug it in again. The top goes to 2, and the denominator goes to, all our hopes are crashed. Unfortunately, there is no limit. I mean, it does not exist, but we have to write the correct answer. So the top is always a positive number. 2 from the left. Give me a number close to 2 from the left, meaning with numbers smaller than 2. Too far? 1.9. Good. So 1.9 minus 2, I only need the sign.
Negative.
So the answer would be, so then x equals 2 is what for this function?